Hi, math lovers. Welcome to notes number 81. I want to go through some properties with you today. So what I want you to think about are your exponents. So a couple times, we've gone back from logarithms to exponents, and we think about like x squared times x to the fourth. If I have the same bases, I can go ahead and I can add my exponents, right? If I have a like x to the fourth divided by x squared, don't I just subtract the exponents, right? And then if I have power to a power, x squared to the third, I go ahead and I multiply my powers together, and that's x to the sixth. So what I want to do today is go back to what we learned before, thinking about our laws of exponents that we have up here, and use those for our laws of logs, okay? So today what we're going to do, they call them the properties of logs, but I like to call them the law of logs because it's more fun to say. So the first product property, if I have a multiplication, I can rewrite this as log base A of x plus log base A of y. And that's based right on this rule up here where I can go ahead and I can add my exponents together. The quotient rule says I'm going to subtract log base A of x minus log base A of y. And that's based on this rule right here. When I have powers in a fraction, I subtract the powers. And then the last one is power to power. So this is a log property. What I like to think about this is this exponent of r here, swirling to the front of that exponent. So let me undo that so you can see that one more time. So what happens is this exponent of r comes all the way to the front here. It swirls to the front, and it's r times the log base A of x. That's such a fun property. Two more things to share with you today. The logarithm of any number, log base A of 1 is always going to be 0. That's a fun one. Okay, anytime you see log base A of any number, you know you're straight to 0. And notice that my bases are the same here, my base and my answer, so therefore it equals 1. So think about it, if I'm going to rewrite this in bacon and eggs, it's a to the first equals a, of course, right? So it has to be 1. All right, so let's go ahead and put these into practices today. Try a couple with you. It says use the properties of logarithms to write each expression. Assume all variables represent positive reals with a not equal to 1 and b not equal to 1. So using that rule that we just talked about above, when I have multiplication, I'm going to rewrite that as an addition problem. So that'd be log base 6 of 7 plus log base 6 of 9. And that's it. That's all they want you to do is to rewrite it in expanded form. This one here with the division, well, that looks a lot like the problem we did up here where we had right here, the division, okay? So I'm gonna go right back to that problem and rewrite it as log base 9 of 15 minus log base 9 of 7. So again, all they want you to do is rewrite that expression. All right, those are the basics. Let's try a couple more. Let me scroll on up to a couple more problems. All right, so I'm not sure I'm gonna have room for all these, but I'll give them a shot. So this first one, well, it doesn't really follow the rules, but if I rewrite this as log base 5 of 8 to the 1/2 power, 8 to the 1/2 power. So then I can take that last rule where I'm going to swirl this exponent right to the front. So I have 1/2 times the log base 5 of 8. And there it is. I rewrote it. Beautiful. Let's do the same thing with letter D. I'm going to rewrite that as a fractional power. So that would be log base A of m to the 2/3 power. We'll take that exponent and swirl it to the front. Such a fun word to say, 2/3 times the log base A of m. And that's it. That's all they want me to do is to rewrite the problem. Okay, then that brings us to these last two. And I know I'm not going to have enough room for these problems. All right, let me see if I can do it neatly. Let me think about this one, E. I've got all of these addition in the numerator, and I've got a division that I'm going to think about as subtraction. So let me first write this as log base A of m times n times q minus, let me think about the division first, log base A of p squared t to the fourth, okay? Now I can rewrite these because they're multiplication. So I can say log base A of m plus log base A of n plus log base A of q. Phew, okay? Then I've got minus log base A of p squared. Now, because I had that minus, I've got to also distribute that minus to the t to the fourth power. So that becomes minus log base A of t to the fourth. And you see what I see? These exponents can swirl. Look at them. They can swirl right to the front. So this becomes, okay, log base A of m plus log base A of n plus log base A of q minus, now let's swirl the two times log base A of p minus 4, swirl the 4, log base A of t. Oh my goodness, look at that. That is a fabulous problem. All right, so I'm going to stop right there, make it a nice quick video for today. I did in your notes sheet, I did question number F. If you want to look at my PDF, that's in your shared folder. You can take a look at that. The second part of the problems here are using the properties of logarithms to condense. So we're going to go the opposite direction. Let me just give you a quick little taste of what these look like. So here, notice that I have an addition sign. So I can write this as log base 3 of x plus 2 times x. And then I have a division sign. That means it's over 2. And if you want to stop there, that's okay. That's okay. Let's do one more. Let's take this 2 that's out in front and I can swirl it to the m power. So that becomes log base A of m squared minus, oh, I get to do another swirl here back to the power of n. So it'd be log base A of n to the third. And because it's a subtraction problem, I can condense it all and write it as one big fraction with one log. Okay. All right, so that's a quick little taste. Oh my goodness. That's a quick little taste there of notes number 81. Enjoy your problem set.